This is question 45 on chemistry from the 2018 NSAA. So the question gives you the contact process where sulfur dioxide and oxygen form sulfur trioxide in a reversible reaction, and you're told that 5 moles of SO2 and 11 moles of oxygen are allowed to reach equilibrium at 450 degrees C, and that 80% of the sulfur dioxides form sulfur trioxide. It then asks you to find the volume of the resulting mixture, given that temperature and pressure are constant, and that the volume of 1 mole of gas under these conditions is 60 decimeters cubed. So where's a good place to start? Well, why don't we try and use as much information that's given to us as we can. We're told that we have 5 moles of SO2 and 11 moles of oxygen at the start, and I find that it always helps to do this sort of diagram, where you have the equation, the moles initially, and the moles at equilibrium. So we can put in 5 and 11 for SO2 and oxygen, and it doesn't tell us anything about SO3, so we can assume that we have none of that at the start. What about equilibrium? Well, we're told that 80% of the SO2 forms SO3, 80% of 5 is 4, so that gives us 4 SO3s and leaves us with only 1 SO2. And so what about oxygen? The coefficient tells us that half as much oxygen is used as SO2 is used. We've used 4 SO2s, so that means we've used 2 oxygens, leaving us with 9. So where to go next? Well, the question's about gases and volumes, and it talks about temperature and pressure. So at this point we should probably be thinking about the ideal gas law, which I always remember as PV equals nRT. But because we're working with volumes in the question, it looks like it might be more useful to use the rearranged form, V is nRT over P. And so what we're told is that the volume of 1 mole of gas is 60 decimeters cubed, but I always like to change the units to meters cubed, because I find that it makes the whole thing simpler and makes it very hard to make unit errors. So let's write this down. When n equals 1, that's 1 mole, V is 0.06 meters cubed, where I've just divided 60 by 1,000 to get the units. And using the law, we substitute n equals 1 into this to get RT over P as being equal to 0.6 meters cubed. So now that we've used everything that we're given, let's try and work out the volume of this mixture. So we know V is nRT over P, and we've already worked what RT over P is, with all of these terms being constant, as 0.06 meters cubed. So all we need is n. We can use what we did at the start to work out n, that's just the total number of moles, which is 1 plus 9 plus 4, which gives us 14, times RT over P, 0.06, which comes out as 0.084 meters cubed. But remember we're in meters cubed, and the answers are given in decimeters cubed, so we change back by timesing by 1,000 to give us 840 decimeters cubed. And this corresponds to answer E on the question paper.